Alright, so in the previous video we just derived this beautiful formula here for the present value of the swap, which basically just expresses it as the notional times the sum of the discounted cash flows, which this zero coupon bond price here expressed at time ti is the discount factor, and you're basically subtracting then this difference in rates, where from the point of view of a receiver swap, since that's what we're assuming, he's receiving a fixed rate K and paying this floating rate, which we now know we can use as the current forward rate for that specific time interval. And so that's the present value of a swap if you're valuing any time, in the future or today, and you just want to know how much is that value to you today. But often whenever you enter into an interest rate swap, there's actually no cash flows that are exchanged at time zero. So at time zero, the swap actually has no value, and is basically set up so that on expectation, each party of the interest rate swap has basically an expected value from this interest rate swap of zero. Of course, one party might win out over the other depending on what these actual realized forward rates are, but at least at time zero, in terms of expectation-wise, there is no value. So that's when a lot of people start talking about what a fair swap rate is, and this basically allows you to introduce yourself to what the definition of a swap rate. Because the swap rate, you'll hear a lot in the markets, is basically the interest rate, the fixed rate K that makes this present value of the swap equal to zero. And this is actually like a very important derivation that we will go over shortly to figure out how to calculate this fair swap rate, because it will show up again and again in later quantitative finance works when you're looking at the swap measures and you're trying to value swaptions, etc. So what we're going to do here to find the fair swap rate for this interest rate swap is basically set this equation that we have here to zero. So when the swap is first issued, solve for the K such that the present value is zero. And so what I'm doing here is I am just rewriting the present value of the swap in a way so I can utilize some techniques here and simplify this formula. So what I'm going to do here is I'm going to substitute for this forward rate here. And I'm going to substitute it using this formula right here that I've written in the forward rate in terms of the zero coupon bond prices. So I've just plugged this guy right here into this guy right here to get this rewritten equation of the swap. And if you distribute this tau I big P, the zero coupon bond price from T to big Ti over, what you're going to get is you're going to have like two components in this sum. And the part with the strike you can just separate off. It's just going to be the sum right here. And for when you multiply this guy with this guy, you'll note that the tau i's cancel out, and the zero coupon bond price expressed at time big Ti will cancel out with this guy right here. And in the end, you're going to be left with this equation, which just expresses the sum of these zero coupon bond prices here. And if you write that sum in the second part of this equation, you'll know that it forms kind of like a telescoping series. For example, at I equals alpha plus 1, this basically becomes negative P of T, T alpha, plus price of the zero coupon bond expressed at time T alpha plus 1, minus price of zero coupon bond expressed at T alpha plus 1. So these guys would cancel. And you get successive cancellations going forward, all the way until you get to T beta. And so you can kind of do the mathematical details for yourself, but once you do that, you will basically, this sum right here reduces to negative n times the zero coupon bond price expressed at T alpha plus n times the zero coupon bond price expressed at T beta. So, and now, fulfilling the promise I mentioned earlier is when we're solving for the swap rate K such that the present value swap is equal to zero, we're going to set this expression here equal to zero. Because this expression is the present value of the interest rate swap. It's just in a different format. It's the same value as this guy right here that we looked at earlier. It's just written solely in terms of zero coupon bond prices now, instead of having forward rates in there. And now it's simple because we can just cancel out the notional amounts. So the notionals are just going to cancel out, and they won't matter at all for the, the notionals are just going to cancel, and they're not going to matter at all for this example. So I'll cancel these ends here. And then if you just solve for the swap rate k, what you'll get is this beautiful equation right here. And this is the forced swap rate. This is the kind of the term we're going to use here. It's also called the fair swap rate. But it's basically, the numerator is the difference between the price of the zero coupon bond at T alpha, big T alpha, which is, if you remember, when the interest rate swap basically starts. Subtract the price of the zero coupon bond expiring at big T beta, and then divide it by this conglomerate sum right here, which is basically, oops, I'm going to add this parentheses right here. It's basically multiplying tau I times the zero coupon bond expiring at time big Ti for I equals alpha plus 1 all the way to beta. So basically all these zero coupon bond prices expiring at these times right there. And for swap rates, it's really important to understand that this is really dependent on the tenor of the swap. And the tenor of the swap is the difference is basically this guy right here. Tenor is T alpha minus T beta. Sorry for my bad handwriting here. I'm using the mouse. But this is the tenor of the swap. And so the swap rate is basically, it will be different for a different alpha and a different beta because you're going to be using different zero coupon bond prices for this. But kind of the key takeaways here, though, is that this fair swap rate is going to change, at each future time t. Because if you go the next day, the zero coupon bond prices will look different because you're in a different yield term environment. And so basically what you'll lead into in the future is this swap rate can also be modeled kind of as a futures unknown rate, and that leads to all sorts of other pricing work dealing with swaptions and more exotic interest rate derivatives. But for the meantime, just understand now that this is the value of the forward swap rate, and this is a very important equation, and it basically allows you to figure out what rate you need to solve for in order, what fixed rate the interest rate swap needs to go to such that the present value of the swap is 0.